Okay, welcome to, thought they were falling, that's funny. Okay, welcome to Algebra 2, Unit 5-3. Here we're going to talk about cube functions and then the inverse, which is cube root functions. So if I go with my parent function of the cube, I might plug in -2, 1, 0, I'm sorry, -2, -1, 0, 1, 2. -2 times -2 is 4 times -2 is -8. -1 times -1 is 1 times -1 is -1. 0 times 0 times 0, 1 times 1 times 1, and 2 times 2 is 4 times 2 is 8. So there's my pairs. How I would graph this, the vertex that I look at is the point that goes right to the origin, then 1, 1, and -1, 1. Then out here at 2 it's 8, and this way. I'm sorry. Out here at 2 it's 8, and at -2 it's -8. You guys graphed this in the last class, so it should look familiar. So if you think about inverse, you're going to be reflecting this over that diagonal and this over that diagonal. Let's look at what happens. You know, inverses also switch this way, so we don't even have to plug it in. You can go -8 is -2, -1 is -1, 0 is 0, 1 is 1, and 8 is 2. Now it is kind of unusual, but a cube root or an odd function can retain the negative. So when we plot these, it's almost exactly like my little mistake just a second ago when I was plotting one. It goes this way. And if you question that, come grab graph paper, draw the diagonal line, and flip it over, and you'll see they truly are inverses of each other. So awesome. Okay, so now we're going to play with a few of these. Let's go ahead and graph the 0.5 x cubed. So we already know -2 cubed is -8. Half of -8 is -4. 1 cubed, -1 cubed is -1. Half of that is -0.5. 0 cubed 0 times 0.5, 0. And now these will just be the positives of those. Okay? You could put it in points, so -2, 4, -2, -4, -1, -0.5, 0, 0, 1.5, and 2, 4. Okay? So now when we get over to the inverse, we already know these points will flip around, but we need to discover what the inverse is. So first thing we do is divide by 0.5. Dividing by 1/2 is the same thing as multiplying by 2. So we go 2, I'm going to switch that to y, equals x cubed. Well, to get rid of the cube, we would cube root, so this becomes cube root 2y equals x. So now does it make sense that 2 times -4 would be -8, the cube root would be -2. And we can go ahead and write all these points in here. -0.5, 2 times out would be -1, cube root would be 1, 0, 0, 0.5, 1, and 4, 2. So now, as we go to graph these, the cube, we notice it actually comes out a lot wider. If you're thinking about transformations, you can explain why using that a value that's less than 1. But here's the interesting part. When we plot the, so this we would say is a vertical shrink because it's squished down to the x-axis, so that's why it's a vertical shrink. When we do the inverse though, look what happens here. Now, that's become a horizontal. Wow. Horizontal shrink. Is that cool or what? So, vertical shrink when it's the fraction in front, but the inverse of that is a whole number in the front of this cube root, and that makes it horizontally shrink. Kind of cool, I hope you think. Okay? So when the a value is greater than 1, like 2x cubed, we would have a stretch. It would make it real, real skinny. Whoops. Real skinny. It stretches away from the x-axis right here compared to the parent function. So when it's stretched away and we flip it, what happens is it's still stretched away, but now this one was a vertical stretch. This one is a horizontal stretch from the y-axis. Stretch. So now when we have the vertical shrink, like I just showed you in the last one, fraction in the front, now inside of here, it's a whole number, it's going to be a horizontal. And so it's going to go real squished in by the y-axis. Okay? Make sure to have that in your notes. You are going to need that. Little bit of information. Okay. We are looking at a formula that shows that you can calculate the approximate weight of a pike if you can measure the length of it. And the way that we came up with this formula is truly measuring pike and weighing them and getting a lot of data until we could establish what a good formula would be in order to do that. So that fishermen didn't always have to weigh the fish, they could actually just measure them as they caught them and know at what point they're getting the amount of weight that they can haul in. So how do we estimate the length of a pike if we have a friend who catches a 7-pound pike? Because oftentimes they won't say how long something is, they'll say, oh, the weight. So we want to have it so it's got the weight in the equation. Obviously what we need to do is get the inverse. So first thing, to get this L alone, we would multiply this by 3,500. So 3,500 WL equals L cubed. Now to get rid of the cubed, we would do cube root. So cube root 3,500. Now we can go ahead and just leave it as weight equals L of W. So we can easily just plug in our cube root 3,500 times 7. 7 times 3,500 is 24,500 cube root. Cube root of 24,500 would be approximately 29. And that would be inches long, because we're looking at how long it is. It was the length depending upon the weight. So that's kind of how you would use it. It's kind of fun to be able to do that when people are talking about different situations and you wonder, I wonder how long that really is. Okay, have a good night.